This is question 20 on maths from section 2 of the 2019 BMAT. So we're told that someone takes the bus and then the train to get to work. Now the probability that the bus is on time is 0.6 and the probability that the bus is late is 0.4. And we're told that if the bus is on time, then the probability that she catches the train is 0.8, but if the bus is late, the probability that she catches the train is 0.6. Therefore, we're asked, given that she caught the train, what is the probability that the bus was on time? So what's a good way of visually representing this data? So with these probability questions, it's usually a good idea to draw some sort of probability tree. So the first choice we have is whether the bus was on time or late. We represent this like so. And then what are the probabilities of each of these outcomes? So we're told that it's 0.6 for the bus being on time. But the answers are given in fractions, and so maybe it would be a good idea to start with the fractions on this tree. So 0.6 is the same as 3/5. And then the probability that the bus was late is 0.4, which is 2/5. And then what comes next on the tree? We have whether she catches the train or doesn't. So let's draw this like so. The tick means she caught the train, the cross means she did not. And so if the bus was on time, the probability that she caught the train is 0.8 or 4/5. And by extension, although it doesn't really matter, we can conclude that it's 1/5 that she doesn't catch the train. Then similarly, if the bus was late, the probability becomes 0.6 or 3/5 that she caught the train. And by extension, it's 2/5 that she does not catch the train. And so now, how can we use this diagram to answer the question that we're asked? So, given that she did catch the train, what is the probability that the bus was on time? And so which parts of this diagram are we interested in? So we want the two paths that lead to her catching the train. So initially, we have the bus being on time and then her catching the train. But also, she could have caught the train if the bus was late by following this path through the tree. So let's work out the actual probabilities overall that she caught the train through each of these paths. So firstly, what is the overall probability that she caught the train and the bus was on time? So when we have an and in that sort of question, we multiply the probabilities together. So we have 3/5 times 4/5. 3 times 4 is 12. 5 times 5 is 25. So this is 12 over 25. Then similarly, if the bus was late, but she caught the train, we have 2/5 times 3/5, which is 6/25. So what we've calculated here is the two probabilities that she caught the train. But is this all we need to do? Well, the intricacy here is that we're told that she did catch the train, and so we're interested in the conditional probability that the bus was on time given this outcome. And so what I mean by that is that we can't simply add these two together to get our probability, because we're only interested in these two outcomes rather than the two that we haven't done. And so how can we convert this into a probability that the bus was on time? So we're interested in the probability of this particular outcome happening, the bus being on time and her catching the train, compared to the total probability of both of these outcomes happening. So we take this 12 and we divide it by the sum of 12 and 6, because that gives us the probability that the bus was on time given that she has caught the train. So this is the same as 12 over 18. 12 over 18 simplifies to 2/3. So this is our final answer, which corresponds to E.